Welcome to my channel. I'm Zhang Xu. Let's work on the problem 61 in chapter 4. This one is a little bit difficult because this time the cable's length changes. So we can see a heavy steel cable. So this one tells you we need to consider cable's mass, right? The length is L and the mass is capital. The length is L, mass is M, and then it is just uniformly distributed the mass, and tell you if the length of a Y hang on one side of the pulley. Another side is L minus Y, right? Calculate the acceleration and then do some calculations. So first thing we can draw the picture. We can see we consider this heavy cable in two parts, M1 and M2, right? And M1 is just Y. M2 is L divided by Y. And because this cable's mass is uniformly distributed, so we can get the mass for M1 is the length Y divided by total length, this L times capital M. Agree? And then because we separated this cable in two parts, another side is the length L minus Y divided by total length L times the capital M. And then we need to do calculations for these problems. First thing we need to find its acceleration, and then we do force analysis. We can see at the object 1 we have gravity, and we have also found the tension. So we can write Newton's second law as the net force equals gravity mg minus m1 ft equals m1 times acceleration. Agree? Yes. And then we look at the net force at this side, because this part when you move down, this part is up. So the net force for this one is Ft minus m2g should equal to m2a. Agree? Yes. Now we can solve these two equations and find the acceleration. This one is just the same thing we did in previous. After we get the acceleration, you can see, because we know m1 and m2 changes with the variable y. So we input the y inside. So input this term m1 and m2 inside. And then we reorganize this equation. We find this acceleration is just as a function of y. See? Now, it looks like we get the acceleration, right? The next one we need to find is we know its initial velocity 0, and then the initial length y0, and then we need to determine its velocity at the moment the whole cable has fallen from the pulley, and evaluate the final velocity at this part. So in this one, it tells us one hint is so important, the chain rule, and do integral. It tells us dv divided by dt. So the derivation v to t is what? Acceleration, right? So it will tell you can write acceleration in this equation is dv derivation for v to y and derivation y to t. And then if you don't know that, you can check with your mathematics handbook. So now we need to find the velocity at one certain time. So we use the hint give us, because we know acceleration as a function of y, and then acceleration can be written at the derivation for v to t, right? Because acceleration is the change of the velocity divided by time, then the hint tells us we can write this dv to dt in this form. And then you can see, when we write it in this form, this term derivation y to the t is just the velocity v. Agree? And this term we keep it dv dy. And you can see, at these two sides, we can write it as 0. 2y divided by L minus 1, then this term times g. And then we put this dy this side, and then v times dv, right? And then in this one, we can do integral at both sides. At both sides, at initial velocity is 0. Final velocity vf at initial y is y0, and the final is L, because it totally fall on this part. Y becomes L, and then we do the integral, and then we find the final velocity, this one. Agree? I then tell you if the y0 is 2 half of the third of the L, we just input this y0 inside and solve the equation to find the final velocity. Thank you.